everyone, welcome to YourPedia. This is Chandrasekhar, Faculty of Electrical and Electronics Engineering at YourPedia. Here in this video today I am going to discuss some very good questions for the interview preparation for NPCIL for Executive Trainee in the branch of Electrical Engineering from the subject Power Systems. You know, for electrical engineers, power system is one of the most important subjects like power systems, electrical machines and power electronics. These are called as core subjects of electrical engineering. I am going to discuss one very good topic, not the complete topic, in fact some questions from that topic from the subject power systems. Yeah, in the subject power system, or if you take practically also, power system stability is very important. Power system stability is very important. Then a question can be asked to you in the NPCIL interview, that is, what is power system stability? When the power system is said to be stable, what is power system stability? This is very easy to understand. The first question is what is power system stability? Yes, what is define power system stability, or explain instead of define, explain. Yes, power system stability. Power system stability. Yeah. This is very simple. See, you need not to go with the definition, exact definition, but your understanding does matters in the interview. That is, see, on our power system, at every instant of time, lot of disturbances keep occurring. What is a disturbance? Then immediately a question can be framed: what is a disturbance? Disturbance means a load increment or load decrement and faults. Yes. At every instant, suppose you are switching off your fan at your home, I can say that is a disturbance, that is reducing the load. You are switching on a lot of fans and I can say bulbs, electric bulbs and AC, air conditioner and all these things that will increase the load at your home, right? So increment or decrement of load is a disturbance. Disturbance means what? The deviation from the existing situation. Suppose now the load on the power system is 500 megawatt. Now if it is suddenly changed to 499 megawatt, 1 megawatt it is reduced, it is a disturbance. Or sometimes fault occurs, a huge fault, I can say triple fault occurred on the transmission line somewhere. That is a very big disturbance. Disturbance are of two types. One is small disturbance and one is large disturbance. The behavior of our power system network for small disturbances and large disturbances is slightly different. Yes, slightly different. So small disturbances we study with help of I can say synchronous machine power transfer equations. It means it's static equations, I can say. But large disturbances, if you study with static equations, you are not going to get the correct result or the practically happening result. Therefore, we have to go with I can say swing equation, mechanical equation of synchronous machine, that is swing equation. See, what is then stability? When a disturbance occurs on the power system network, if the system is able to regain its actual position. Suppose, what does it mean by position? Now your synchronous generator is operating at a load angle of 36.86 degree. Now a disturbance has occurred at 36.86 degree. The machine is stable. The machine is working stably. Now when a fault occurs or a disturbance occurs, if it is a large disturbance or small disturbance, definitely there will be either increment or decrement in the angle, right? In the that load angle. It will make some oscillations if it is large disturbance. If it is large disturbance, it will make some recognizable oscillations. In our study, we will study those oscillations. After making those oscillations again, if the load angle or if the machine finds one stable point, what is a stable point? It is a point at which acceleration power is 0, means the output power is exactly equal to input power. What is acceleration power? PA. Yes, let me write the acceleration power PA is equal to input is steam input and output is electric power output. Now this is a new one. Previously, see, this is PA1 I call, this is PA2 I call. PA1 is equal to PS minus P1. Previously, when there is no disturbance, P1 is exactly equal to this PS. P1 is exactly equal to this PS, and there is no acceleration. Means the rotor neither accelerates nor decelerates. It is going to be stably operated at that point. But when disturbance occurs, this PE1 change it to PE2, then my rotor must find, my rotor angle must find a point where it has to be stably sit at a point where this PE2 is exactly equal to again PS. I need not to write this one as PS1 and PS2. Let me keep it as PS. For here, I can say visualization purpose. I'm drawing one diagram. See, this is the power variation of synchronous machine. This is 0, this is pi. See, from 0 to pi, it acts like generator. Beyond pi, it is going to act like a motor. This is P max. That is P max. Do not misunderstand that PM stands for P mechanical. PS is steam input. This is the mechanical input what we are giving. This is the mechanical input what we are giving. Now here it is operating at this angle delta naught. It is operating. After making oscillations again, if it is able to come back to this position, and at that position two things must satisfy. One is at that position anyhow PA is equal to 0, and here before this disturbance this rotor speed is equal to synchronous speed. After making oscillations again, it comes back to that position with omega r is equal to omega s. Then that power system network is said to be stable. This is very simple to understand. Understand. Okay, our existing power system network is stable now. Means there is no acceleration, there is no deceleration, there is no increment in power, decrement in power. The load is equal to, means the power supplied is equal to load. For time being, we are neglecting the losses. Or if you take losses also, see, the power supply is equal to load plus losses. But all of a sudden, power demand increased. Means this is more. Means PE is more than PS. Then rotor will start. PA is equal to PS minus P. If P increases, rotor will decelerate. Its speed, rotor speed will decrease. But after some time, with the help of the increment in mechanical input, again if it regains its original speed, and that is equal to that of PE, and both are equal, PA is equal to 0, and rotor speed is exactly equal to synchronous speed, then that point is said to be stable. So after experiencing a disturbance, again if it finds a point where PA is equal to 0 and omega r is equal to omega s, then only our power system network is said to be stable, right? There are a few more questions on the stability. Yes, these are the previously asked questions on the stability. The basic question, they'll start with from very basic question, that is, what is a stable power system network? Now, the next question is define steady state stability limit and transient stability limit. What is steady state stability limit? For small disturbances, the maximum power change in power for small disturbances. I can say, yes, I can say here, see, PE is equal to P max into sine delta. This is called as steady state stability limit. Means for small disturbances, maximum power up to which it can go. Means suppose I'll take here, this is delta load angle, this is electric power output axis, and this is your actual electric power output. Now slowly, if the load angle is, if the disturbance is small, present it is operating here, this is a delta naught. Means you can, if you are increasing slowly, if your load is increasing slowly, up to P max you can go, okay, for small disturbances. But if the disturbance is large, what kind of disturbance are large disturbances? I can say the faults are large disturbances. If you are operating here, suppose suppose this is a delta 1. If a small disturbance occurs, it may go here and it will stop here itself. But if a large disturbance came, it will enter into unstable region. Means that is the difference between steady state stability limit and transient stability limit, right? And the steady state stability limit is more than transient stability limit. Okay, for in steady state you can go for more, you have more limit, but in transient the limit is less. Okay, next one. Why after steady state stability limit the synchronism will be losing? So this is steady state stability limit. If you I can say go beyond this one, though your load is increasing. See, when load increases, load angle increases. But see, in power system, especially in synchronous machine, when load is increasing, load angle will increase. If load angle increasing, power is also increasing. Initially, load angle, Initially load angle is here, power is here. After that load angle is increased, then power is increased from here to here, right? When load increases, load angle increases and power increases. But that is going to happen up to pi by 2 radians only. Pi by 2 radians only. After that, once you cross this steady state stability limit, though your load is increasing, load angle is increasing, but power supply is decreasing, which is not correct. Therefore, once it crosses steady state stability limit, synchronism will be lost. Okay, among steady state stability limit and transient stability limit, which one is higher? Obviously, steady state stability limit, but because the disturbance is smaller one, right? Next one. Give some methods to improve steady state stability limit. What is steady state stability limit? As I told, Pmax is equal to, let's take some different color instead of this color. Yes, what is steady state stability limit? That is Pmax. Pmax is equal to mod Vs, mod Vr by X. What are some methods, some possible methods are decrease the reactance X. Suppose transmission line is there, you decrease the transmission line reactance. How to decrease transmission line reactance? Connect a series capacitor, that is one method, and go with the parallel transmission line, that is another method. Go with the bundle conductors, that is another method. So decrease reactance is one method. Or you operate at a very high voltages, therefore Vs, Vr will be increased. Increase the excitation, that is another method. These are the possible methods of improving steady state stability limit. Means with that Pmax is, see P is what? P is equal to Pmax into sin delta, and this is steady state stability limit. Steady state stability limit is this. Observe. Suppose if this is increased, obviously this has to decrease, then delta will decrease. How much less is the load angle, that much more my system is stable, and the same power you are delivering. See, if you are operating at 85 degree, you are sending 500 megawatt. But you are operating at 15 degree, but still you are able to send 500 megawatt. Which case is advantageous? 15 degree, 500 megawatt. Why? If you are at 15 degree, though the disturbance is large, it may go from 15 degree to 60 degree. But you are already operating at 85 degree. Even a small disturbance also can make your angle to cross 180 degrees, right? So it is always by keeping transient faults, or by keeping large disturbances or faults on account or operating generally the synchronous machine or load angle will be operated from 30 to 40 degrees. Even in fact I can say near to close to 30 degrees, not even 40 degrees also, right? Yeah. Now, how can you reduce reactance of the line? As I told, the reactance of the line can be reduced with a series, I can say capacitor, X minus XC. As XC is there, no, that overall X is reducing. And with parallel transmission lines, if you are taking two parallel transmission lines, X in parallel with X will be X by 2. With bundle conductors, these are the methods to reduce transmission line reactance, right? So, what is the purpose of series reactance? Yes, series reactor is going to serve two purposes. One, it is going to improve power system stability. Another is it is going to improve the voltage. Yes, series reactance. And next question they may ask is, what are the disadvantages of series capacitor or reactance? The purpose of series capacitor, not reactance. This is series capacitor. Please change it. What is the purpose of series capacitor? Yes, we have these are the advantages of series capacitor. Yes, series capacitor. With series capacitor, what happens is X is equal to X line minus XC. The overall X is decreased. Then Pmax increases. That implies delta decreases. That implies stability improves. That implies stability is improved. That is one advantage. Another advantage is series capacitor improves voltage. Series capacitor, yes. Series capacitor improves yes voltage. Yeah, for the purpose of voltage I can say improvement, we use series capacitor. Shunt capacitor also can improve the voltage, but shunt capacitor is not going to decrease this series reactance, and stability cannot be improved by shunt capacitor. Shunt capacitor improves power factor, but whereas series capacitor is unable to improve the power factor. Series capacitor cannot supply reactive power. It will supply very small, negligible amount of reactive power. Okay, but shunt capacitor is going to supply good amount of reactive power, with which power factor can be improved, right? And what is the disadvantage of this one? I will tell you. What is the disadvantage of series capacitor? The disadvantage is what is the fault current? Fault current is equal to V by X without XL. IF1 without series capacitor. What is IF2? That is V by XL minus XC. As this is decreased, fault current is increased. IF2 is greater than IF1. As fault current increases, fault MVA increases, then I can say the power system protection equipment, that is a circuit breaker rating requirement, is more. Means this series capacitor is increasing the fault level, which is undesirable, which is not desirable for us. This way questions can be asked. This is one of the very good topic. Power system stability is one of the very good topic to understand, because it includes power system stability includes transmission lines and synchronous machines, both synchronous machines, and a bit of network analysis and the concept of power factor and fault analysis. All these things are included in this topic. Therefore, it's a potential topic to be asked in your NPCIL interview. All the best, ma. Join your hands with YourPedia to accelerate your preparation towards NPCIL. Here, NPCIL Executive Trainee interview preparation. Here in YourPedia, we will take unlimited number of snap interviews. What is a snap interview? I'll tell you. You first interact with the mentor. A mentor will tell you how to prepare, what to prepare, from where to prepare, and all. Then the mentor will ask you to prepare the subjects parts wise. Suppose if I am the mentor for power system, I'll tell you to prepare transmission. You prepare transmission and give me interview. It's a one-to-one interview, mock interview means. Sorry, snap interview means one-to-one interview. Even mock interview means there will be 4 to 5 people on the panel, and they will take your mock interview, which similar to NPCIL actual interview. In snap interview, you will be interacting with faculty for 15 minutes. Faculty will be asking questions from that subject, which includes previously asked questions and some good innovative questions which can be asked in NPCIL interview. And with the questions are like those questions will check your thinking ability, right? And in the last 5 minutes, faculty will be giving feedback. Like that, you can give on each subject any number of snap interviews. Once you are comfortable in the snaps, then faculty will tell you to go for mock interview. In mock interview, there will be 3 to 4 or sometimes 4 to 5 people will be there on panel, and they will take your mock interview, which is similar to, I can say, actual interview of NPCIL or BARC, right? So join your hands with YourPedia to accelerate your preparation of NPCIL executive training in the branch of electrical engineering. Thank you.